So next is question number 5. For a sample of water with the ionic composition shown below, the carbonate and non-carbonate hardness concentration in milligram per liter as CaCO3 respectively are. So here the table is given. The values are in milli equivalent per liter, and I have to calculate the carbonate and non-carbonate iron hardness concentration. Okay, so from this chart we can see that the Cas2 plus Ca2 plus ion concentration is 4 minus 0 milli equivalent per liter, that is 4 milli equivalent per liter, and Mg concentration is 5 minus 4, that is 1 milli equivalent per liter, and HCO3 minus concentration is 3.5 minus 0, that is 3.5 milli equivalent per liter. So we have these values. Now hardness. What is hardness? What is hardness? Hardness is nothing but it is due to the multivalent metallic cations. So hardness is due to the multivalent metallic ions or cations, to be specific, multivalent metallic cations. Okay, so sodium is a metal, but it is single valency, so it is not a multivalent metallic cations are Ca and Mg, so it will create hardness. So the total hardness, we can say total hardness is equal to concentration of Ca ion is 4 milli equivalent per liter. Hardness, one thing also we should remember, that hardness is always given as CaCO3. Okay, so 4 into 50, that is we are going to multiply it by the molecular weight of CaCO3, equivalent weight of CaCO3 plus this is Ca and Mg is 1 into 50. So now we got it into milligram per liter as CaCO3. So this is the total hardness. So it comes as 200 plus 50, 250 milligram per liter as CaCO3. Okay, so this is the total hardness. Now alkalinity, if we want to calculate alkalinity, so alkalinity is due to the presence of, is always due to the presence of HCO3 minus ion only. Alkalinity is always present due to SCO3 minus ion only. Okay, now so the alkalinity also we can calculate, that is SCO3 is 3.5 into 50, this is milligram per liter as CaCO3. So this is about 175 milligram per liter as CaCO3. Okay, now we know that what is carbonate hardness. Carbonate hardness is nothing but the, so carbonate hardness, it is minimum of, carbonate hardness is minimum of total hardness total hardness or alkalinity. Okay, so minimum of 250 and 175. So the carbonate hardness that came here, it is 175 milligram per liter as CaCO3. This is carbonate hardness, and non-carbonate hardness is nothing but NCH, that is total hardness minus carbonate hardness. Total hardness consists of two types of hardnesses, which is carbonate hardness and non-carbonate hardness. We know total hardness now, we know carbonate hardness now. Now I can calculate the non-carbonate hardness. So that is total hardness, that means 250 minus 175. It comes as 75 milligram per liter as CaCO3. So the answer should be carbonate hardness 175, non-carbonate hardness 75. Is there any option like this? So the carbonate hardness is 175 and non-carbonate hardness is 75. Option B is the answer. Okay, let us see the next question, which is question number 6. Some of the non-toxic metal normally found in natural water are. Now we need to know what types of metal are toxic and what types of metals are non-toxic into the water. There are some options like arsenic, lead, mercury, calcium, cadmium, sodium, silver, chromium, copper, iron, manganese, magnesium. So we should know which type of the metals are toxic and which should be avoided into the water. So the metals which are naturally found in the water are classified into toxic and non-toxic metals. So toxic metals are cadmium, lead, that means Pb, mercury, that means Hg, silver, that means Ag, arsenic, that means As, and barium, that means Ba. These are the toxic metals that are present into the water. And non-toxic, so the non-toxic metals which are present in water are sodium, that is Na, and sodium has permissible values 50 to 250 milligram per liter. And we have copper. Copper is also permissible, it is also non-toxic, so 0.05 to 1.5 milligram per liter. Calcium, Ca, it is also and up to 60 milligram per liter is permissible. Zinc is also okay, it is also non-toxic and it is 5 to 15 milligram per liter is good. Manganese, permissible value is 0.05 to 0.5 milligram per liter. And magnesium is also non-toxic up to 40 milligram per liter. And lastly, iron. Iron, permissible value is 0.1 to 1, it is okay, 0.1 to 1 milligram per liter. So in the options we can see option arsenic, lead and mercury, totally unacceptable. Calcium, sodium, okay, but silver is not at all okay. Cadmium, no. Copper is good. Chromium, no. So the option D, iron, manganese and magnesium is good. Okay, so this is question number 6. So now let us do the question number 2, which is The analysis of a water sample revealed that the sample contains the following species. So these are the compounds that are mixed in sample of water. Concentration of which of the species will be required to compute alkalinity? See, what is alkalinity first of all? So alkalinity is nothing but the ability to reduce acidity of water, right? So ability to reduce acidic compounds, or better we'll use neutralize. Ability to neutralize the acidic compounds. Okay, so alkalinity is by the compounds such as CO3 2-, we get Na plus will not give any acidity or alkalinity, it is just a mineral. Aluminium just a mineral, this is just a mineral. Chloride no, and Fe, iron just a mineral, manganese just a mineral, calcium just a mineral. So remaining CO3, so we are remained with CO3 2-, H plus, H2CO3, SCO3-, and OH-. These 5 compounds are remaining. In these 5 compounds, we should remember that H2CO3 and HCO3- can never come together. Both are same only one hydrogen is there, it is reacted with hydrogen, so both are same, so only one can be there. So the best option will be, see, in the second option there is H2CO3 SCO3- together. So the only option remain is option A. So the correct answer is option A. So next, the question number 3 is, as per IS 10500/2012, for drinking water in the absence of alternate source of water, the permissible limits for chloride and sulfate in milligram per liter respectively are. So we need to get the permissible limit in absence of alternate source of water. So the list follows like this. So as per IS 10500/2012, following are the various permissible limits of different parameter. So first of all, it is total suspended solids. We should know all the parameters and we should remember that. So the first is total suspended solids. Total suspended solids acceptable limit is 500 milligram per liter. And if there is no other alternate source, we can go up to 2000. This is total suspended solids. Turbidity 1 NTU acceptable. No alternate 5 NTU. Color 5 TCU, 25 TCU. So like this we should remember. Most important is alkalinity is 200 if there is, this is the standard limit, and if there is no alternate we can go up to 600. And pH 7 to 8.5, and if there is no alternate less than 6.5 is also okay, and greater than 9.2 is also fine. Hardness is same as alkalinity, that is 200 and 600. Chloride content, so in this question we have asked about chloride content and sulfate. Chloride content is 250 milligram per liter if it is permissible, and if there is no alternate source we can go up to 1000 as well. Sulfate 200 permissible limit, 400 can go up to when we don't have any alternate limits. And nitrate, we should remember, it is 45. Nitrate is 45. There is no relaxation. If there is no alternate source, we cannot go up greater than 45. And fluoride 1 up to 1.5 is okay if there is no alternate source. Iron Fe, iron or Fe, it is 0.3. And no relaxation in iron and no relaxation in nitrate. So for us, chloride content can go for 1000 and sulfate can go up to 400. So the options which are matching, it is alternate source. See, there is options. See, for chloride we have just now seen permissible limit of chloride is 250 and permissible limit of sulfate is 200. Okay, there are two types of options. See, if we only see, if we anyhow we read the question lightly and we miss this alternate source of water, this alternate word, if we miss, then our marks will be in negative. Why? They have given option 250 and 200 as well. 250 is chloride limit and 200 is sulfate's limit. But no, there is about alternate source, so which is 1000 and 400. So this is answer number 3. Now let's go to question 4. A groundwater sample was found to contain 500 milligram per liter total dissolved solids. TDS in percentage present in the sample is, so they are asking about TDS in percentage. Just now we have seen the total dissolved solids permissible limit or standard limit is 500 milligram per liter. First of all, we should know what is TDS, right? Total dissolved solids. What type of solids can come into total dissolved solids? So they are suspended solids plus dissolved solids. Okay, suspended solids plus dissolved solids. So two types of solids can come into the total dissolved solids, and the standard limit of total dissolved solids in any water sample is 500 milligram per liter. This we need to change into percentage. Okay, per liter of what? Per liter of water, right? And for water we know that its volume and its mass is equivalent, right? So 1 liter for water, 1 liter of volume is equivalent to 1000 grams of water mass. So 500 milligram per 1000 gram, and now I can change milligram also in gram. So 500 into 10 to the power minus 3 divided by 1000 gram upon gram. So gram to gram cancel, I have to change it into percentage. So it will be 10 to the power minus 3 upon 1000 into 100. So now it has changed in percentage, and it is coming like 10 to the power minus 3, 10 to the power minus 4, 0.05 percentage. So the option is, so I can write the answer is 0.05. So this is question number 4. So next is question number 5. For a sample of water with the ionic composition shown below, the carbonate and non-carbonate hardness concentration in milligram per liter as CaCO3 respectively are. So here the table is given. The values are in milli equivalent per liter, and I have to calculate the carbonate and non-carbonate iron hardness concentration. Okay, so from this chart we can see that the Cas2 plus Ca2 plus ion concentration is 4 minus 0 milli equivalent per liter, that is 4 milli equivalent per liter, and Mg concentration is 5 minus 4, that is 1 milli equivalent per liter, and HCO3 minus concentration is 3.5 minus 0, that is 3.5 milli equivalent per liter. So we have these values. Now hardness, what is hardness? What is hardness? Hardness is nothing but it is due to the multivalent metallic cations. So hardness is due to the multivalent metallic ions or cations, to be specific. Multivalent metallic cations. Okay, so sodium is a metal, but it is single valency, so it is not a multivalent metallic cations are Ca and Mg, so it will create hardness. So the total hardness, we can say total hardness is equal to concentration of Ca ion is 4 milliequivalent per liter. Hardness, one thing also we should remember, that hardness is always given as CaCO3. Okay, so 4 into 50, that is we are going to multiply it by the molecular weight of CaCO3, equivalent weight of CaCO3 plus this is Ca and Mg is 1 into 50. So now we got it into milligram per liter as CaCO3. So this is the total hardness. So it comes as 200 plus 50, 250 milligram per liter as CaCO3. Okay, so this is the total hardness. Now alkalinity, if we want to calculate alkalinity, so alkalinity is due to the presence of, is always due to the presence of HCO3 minus ion only. Alkalinity is always present due to SCO3 minus ion only. Okay, now so the alkalinity also we can calculate, that is SCO3 is 3.5 into 50, this is milligram per liter as CaCO3. So this is about 175 milligram per liter as CaCO3. Okay, now we know that what is carbonate hardness. Carbonate hardness is nothing but the, so carbonate hardness, it is minimum of, carbonate hardness is minimum of total hardness or alkalinity. Okay, so minimum of 250 and 175, so the carbonate hardness that came here, it is 175 milligram per liter as CaCO3. This is carbonate hardness, and non-carbonate hardness is nothing but NCH, that is total hardness minus carbonate hardness. Total hardness consists of two types of hardnesses, which is carbonate hardness and non-carbonate hardness. We know total hardness now, we know carbonate hardness now. Now I can calculate the non-carbonate hardness. So that is total hardness, that means 250 minus 175. It comes as 75 milligram per liter as CaCO3. So the answer should be carbonate hardness 175, non-carbonate hardness 75. Is there any option like this? So the carbonate hardness is 175 and non-carbonate hardness is 75. Option B is the answer. Okay, let us see the next question, which is question number 6. Some of the non-toxic metal normally found in natural water are. Now we need to know what types of metal are toxic and what types of metals are non-toxic into the water. There are some options like arsenic, lead, mercury, calcium, cadmium, sodium, silver, chromium, copper, iron, manganese, magnesium. So we should know which type of the metals are toxic and which should be avoided into the water. So the metals which are naturally found in the water are classified into toxic and non-toxic metals. So toxic metals are toxic metals are cadmium, lead, that means Pb, mercury, that means Hg, silver, that means Ag, arsenic, that means As, and barium, that means Ba. These are the toxic metals that are present into the water. And non-toxic, so the non-toxic metals which are present in water are sodium, that is Na, and sodium has permissible values 50 to 250 milligram per liter. And we have copper. Copper is also permissible, it is also non-toxic, so 0.05 to 1.5 milligram per liter. Calcium, Ca, it is also and up to 60 milligram per liter is permissible. Zinc is also okay, it is also non-toxic and it is 5 to 15 milligram per liter is good. Manganese, permissible value is 0.05 to 0.5 milligram per liter. And magnesium is also non-toxic up to 40 milligram per liter. And lastly, iron. Iron, permissible value is 0.1 to 1, it is okay, 0.1 to 1 milligram per liter. So in the options we can see option arsenic, lead and mercury totally unacceptable. Calcium, sodium okay, but silver is not at all okay. Cadmium no. Copper is good. Chromium no. So the option D, iron, manganese and magnesium is good. Okay, so this is question number 6. Okay, let's do the question number 13, which is the organism which exhibits very nearly the characteristics of an ideal pathogenic indicator is, there are 4 options in which the correct option will be option B, which is Escherichia coli, Why Escherichia coli? Because see, there are other options: Entamoeba, Histolytica, Salmonella typhi, Vibrio cholera, but these options are not viable because Escherichia coli is the ideal pathogenic indicator used for bacterial analysis of water. It is used for bacterial analysis of water. See, it is a fecal indicator. It indicates the presence of fecal contamination. Fecal contamination. So it is a type of bacteria that lives normally in human intestine, and it also found in the gut of some animals. Most type of E. coli, we can call it E. coli as well. Most type of E. coli are harmless and even help keep your digestive tract healthy. They are harmless, they are good for us, but some strains can cause diarrhea if we eat contaminated food or drink foul water. So, Escherichia coli, it's itself harmless, but the presence of this bacteria may indicate that we can have some serious contamination into the water. So it is the ideal pathogenic indicator to check if there can be other pathogens in water or not. So the option is option B. Now let's move to question number 14, which is the results of analysis of raw water sample are given below. Turbidity 5 milligram per liter. They have given us the turbidity 5 milligram per liter. Let's highlight this. 5 milligram per liter. pH 7.4. Fluoride 2.5 milligram per liter. Total hardness 300. Iron 3 milligram per liter. MPN 50 per 100 ml. Okay. Now we have to check what is needed to be removed. So from the data given above, it can be inferred that water needs removal of what are the things that should be removed from the water, what are in the safe limit and what should be removed. So I have discussed in previous lectures about the specific parameters of water and their acceptable limit and permissible limit in absence of any other alternate source. So here see, turbidity acceptable limit 1, but we can manage with 5 as well, right? So 1 to 5 is okay, turbidity. And next is pH value. They are asking pH is 7 to 8.5 and we have the pH 7.4 in the question. This is also good. Then fluoride. Fluoride content should be equal to 1. It should be acceptable limit should be 1. Can go up to 1.5 but not more than that. So 1 to 1.5. And fluoride content is also given 1 milligram per liter. So fluoride okay. pH okay. Turbidity they have given 3.5 NTU. This is also fine. Now we have iron. Iron limit is 0.3 and there is no relaxation. No relaxation. That means less than 0.3 is only the only option we can say. So iron, but they have given in the water iron is 2.7 milligram per liter. So iron is not acceptable. We need to do the removal of iron. And then total hardness. See, total hardness 200 is the acceptable limit. But in any other sources it can go up to 600. So 200 is the acceptable and we have given 350 milligram per liter. So hardness should also be removed. 600 is the case when there is no alternate options. For hardness, let's consider that there is No other, there are other options, but acceptable limit is 200. So if we see the question, the options that match, we have turbidity into the limits. Turbidity okay, turbidity is okay, pH okay, fluoride not okay, to iron not at all okay, mpn we have to remove. We don't want any bacteria, there is no relaxation of bacteria into the water, so it will always be removed. Bacteria, any pathogen we don't need, so there will be a disinfection process, definitely, because we don't want any pathogens, right? Now the best option that matches is see, iron followed by disinfection, fluorides hardness and iron followed by disinfection. No, yes, the option will be hardness iron followed by disinfection. This is the perfect, because fluoride is also higher limit, right? So fluoride is also greater than 1, so it is 2.5 fluorides, and then hardness is also removed. See, fluoride and disinfection is all very necessary in this question, and fluoride and disinfection are not both in these three options, so only option left is option number D, so it is the correct answer. Now question 15, in natural water hardness is mainly caused by what things? So see, hardness is caused by the presence of carbonates, bicarbonates and sulfates, chlorides of what? Of calcium and magnesium. Calcium and magnesium, we can say aluminum sometimes. These are all multivalent cations. Hardness is never caused by any single valent cations. For example, sodium Na+, hardness is not caused by this, and potassium K+, hardness is not caused by this as well. We need multivalent cations, Al3+, so these things will work. And also they are carbonates, bicarbonates, sulfates and chlorides only. And so in natural water hardness is mainly caused by, we have the option calcium and magnesium. Mainly means generally it is caused by calcium and magnesium, so option number D. Next is temporary hardness in water is caused by the presence of, say, now just now we studied about hardness, right? Now temporary hardness. So the temporary hardness is caused by the presence of bicarbonates. So this bicarbonate only, this will create what? It will create the temporary hardness. Only by bicarbonates. Bicarbonates can also, it is written as SiO3 minus. Okay, so it is SiO3 minus. So the option will be bicarbonates and other things, carbonates, sulfates, chlorides will give you the permanent hardness. So only bicarbonates of calcium and magnesium will give the temporary hardness. Next is blue baby disease. Methemoglobinemia in children is caused by the presence of, see, the blue baby disease is caused by the presence of nitrates. It is caused by the presence of nitrate. See, nitrate limit is 45 milligram per liter. In absence of any alternate source also, it is 45 milligram per liter. If there is slightly greater value of nitrates, it will cause blue baby disease. See, nitrate will what is blue baby disease? See, nitrate sucks out all the oxygen of the water, right? So if small babies have this water, they don't get proper oxygen supply in their body because nitrate is there, it is just sucking out all the oxygen. So the babies are not able to breathe properly, they suffocate and they turn bluish, that because they don't get the proper oxygen intake. So only this disease is named as blue baby disease, and the scientific name is methemoglobinemia. So the answer is nitrates. Now 18. The microbial quality of treated piped water supplies is monitored by, see, microbial quality of treated piped water supply is monitored by, we have only one option, that is coliform MPN test. Coliform MPN test they do to check if there is any E. coli bacteria colony. If it is present, just because it is indicator of any pathogen, so they will be just ready that yeah, there can be any pathogen. So coliform MPN test is the most suitable test. Now next question is excessive fluoride in drinking water causes. See, if there is excessive fluoride greater than 1, we can say milligram per liter, or max to max 1.5 milligram per liter, there will be mottling of teeth, bones will be brittle, teeth will be brittle, they will be mottling. So the option will be option B. So the question number 20 is alkalinity of water can be defined correctly by one of the following ways. There are 4 options. One is, it is the measure of ability of water to neutralize oxygen. Next, measure of ability of water to neutralize carbonates. Measure of ability of water, it is the presence of iron in water that will neutralize hydrogen ions. It is the measure of ability of water to neutralize hydroxides. Okay, so there are 4 options. So alkalinity is the capacity of water to neutralize the acid. It is the capacity of water to neutralize any acid solution. So of water to neutralize any acid solution. Okay, so the option will be acidic solutions are made up of H plus ions, right? And alkaline solutions are made up of OH minus ions. So because it is alkalinity is neutralizing the acid ion, that means it is the presence of ions in water that will neutralize hydrogen ion. Option number C is correct. The next question, Ambient index is measure of one of the following. As we have already discussed, Ambient is the measure of the coliform bacteria. Next, question number 22. The most important water quality parameter for domestic use of water is, see, this in this question we have to give the answer based on our logic. Like they have given carbonate hardness, they have given the option of non-carbonate hardness, option of coliform group of organism, option of chlorides. See, the first and foremost thing which is important is our health. Carbonate hardness will not create any immediate result on our health. Non-carbonate as well and chlorides as well. But this coliform group, it can create harmful diseases in our body. So the coliform group of organism test is very much important. This quality of parameter should be taken very seriously. Next, 23. Presence of fluoride in water greater than permissible level of 1.5 mg per liter causes cardiovascular disease, methemoglobinemia, hepatitis, dental fluorosis. C. For fluoride less than 1 milligram per liter. This is also not good for our body because it causes dental cavities. And fluoride greater than 1.5 milligram per liter is also not good for our body because it creates mottling of teeth, that is known as dental fluorosis. So the option will be dental fluorosis. So we should know that fluoride should be in between 1 to 1.5. This much is needed for our body. Now next is 24. The temporary hardness of water is caused by, we have already discussed, temporary hardness is caused by bicarbonates of calcium and magnesium, that is not there. So we can take bicarbonates and carbonates of calcium and magnesium. Temporary hardness can be removed by the boiling process, that can be removed. So by the boiling we can remove bicarbonates and carbonates of the hardness. Next question is question 25, which is bacteriological examination of drinking water for Escherichia coli, we can say in short E. coli, is performed because, see, this question is so important. We have seen so many times this E. coli, MPN test. So this bacteriological examination of drinking water is very much important. You should be focusing on this also. So the option is, they are pathogenic causing intestinal disease, E. coli. Their presence indicate viral contamination of water. They are used as indicator organisms for probable presence of pathogens. They represent unique indicator organism for sewage pollution. As we have already discussed that they act as indicator for the probable presence of pathogens. So the option number 3 is most suitable. Next is methemoglobinemia. The blue baby syndrome is caused by consuming water containing excess. As we have already discussed, it is because of the nitrate, because nitrate value should be upper limit should be 45 milligram per liter. If it is greater than that, it will just try to biodegrade and it will use all the oxygen and it will create blue baby syndrome. So the nitrate is the correct option. Nitrite is not the problem. Nitrite is the last stage, that is good. That indicates that all the deoxygenation has happened and water is now properly cleaned. So nitrite is not a problem, but nitrate shows that there is something that needed to be removed and the water should be treated. Next is hardness of water is caused by the presence of which of the following in water? Hardness. As we know, hardness is followed by calcium and magnesium ions of inside the water. So the option will be option B. Next is the question 28. The pH of water admitted into a treatment plant was 6 in the morning, consequent to inflow of raw water from a different source. It changed to 8 in next 24 hours, assuming linear variation in time of the hydrogen concentration. Time mean pH value of the water over this 24 hours period is, so they are asking the mean. We can say in 24 hours what will be the mean value of pH in the water. Initial value was, so the value of pH initially was, I can say like pH I is the initial, it is 6. Okay, pH final they are saying is 8, and it took time 24 hours. Now I can say the concentration of H plus ions initially is what? 10 to the power minus of pH. So minus 6 moles per liter, and H plus ion concentration finally was 10 to the power minus 8 moles per liter. See, pH is increasing, pH value is increasing, that means it is going to alkaline side. So the concentration of H plus ion is decreasing from 10 to the power minus 6 to 10 to the power minus 8. And they are saying that we need to assume linear variation in time. Okay, so we can say of what? Of the hydrogen ion concentration. So if I plot a graph between what? Time, okay, time in hours, and because they are saying linear variation, right, and into the concentration of hydrogen ion. So H plus ion concentration in moles per liter, they say that it is decreasing from 10 to the power minus 6 to 10 to the power, let's say this is minus 8, 10 to the power minus 6 to 10 to the power minus 8. Right, approximately this much in 24 hours. So in 24 hours, okay, this is 0, right? Okay, so we have to find the average of time mean concentration. We can just simply put the average concentration as nothing but simple average concentration. How do we calculate average of two things? 10 to the power minus 6 plus 10 to the power minus 8 divided by 2. It gives us 5.05 into 10 to the power minus 7 moles per liter. So we got the H plus ion concentration average. Now I can get the average pH value, which will be minus of log H plus average minus of log value. So minus of log what? 5.05 into 10 to the power minus 7. It comes out to be 6.296 pH average. This is the answer. So the answer will be 6.296. They haven't said about up to how much decimal value, so I have got the answer 6.296. I can put it there. So this is the all 1 mark questions which came in GATE 2000. In the quality of water, quality parameter of water in previous years, not about any specific year. It is all previous year 1 mark question, and we can see by the analysis the quality parameters which are most important are fluorides, we can say hardness, alkalinity, non-carbonate, carbonate hardness, we can say nitrates, we can say um, how the hardness is created, temporary and permanent. We can, most important is mpn. What is mpn, what is E. coli? So these are all the things. What are the diseases which caused by some values? What should be the approximate value, like what is the acceptable limit for all the things? So we should remember some of the values. I hope you guys understood what is the basic idea of 1 mark quality parameter of water question from environment engineering. Let us discuss the 2 mark question now.